Hello again. In this session, I'm going to talk about powers, all about powers. So our session is about powers. First of all, let's talk about the definition of a power. What is a power? What is 2 power 3, for example? This is 2 times 2 times 2, 3 times, which is equal to 8. Again, if we have 3 power 4, for example, it's 3 times 3 times 3 times 3, 4 times, which is equal to 81 if you want to calculate it. So the formula is a exponent n is equal to a times a times a, etc. times a, and we have here n a's. So n times. This is the definition of an exponent. Let's take an example with negative numbers. If we have, for example, minus 2 power 2 exponent 2 is equal to minus 2 times minus 2, which is equal to minus times minus is a plus, and 2 times 2 is 4, which is equal to plus 4. Okay, and whenever we have a power, a power n, this we call it the base of the power, and here is called exponent or the power. So we can read it a exponent n or a to the power n. Okay. Now let's talk about the properties of the power. First, we have to know that if we have 2 power 1, it's the same as 2, since it's 2 multiplied by itself 1 time, so it's 2. So a power 1 is equal to 8. So whenever we have no exponent here, it's exponent 1. That is, if we have, for example, 3, it is the same as 3 exponent 1. Okay. This is the first one, and the second property I want to talk about is a exponent 0. What is a exponent 0? It's equal to 1. Everyone raised to power 0 is equal to 1, and I'm going to prove this at the end of the properties. Everything, if we have, for example, 3 exponent 0 is equal to 1. Another example, if we have 2 minus 3 times 101, all of that exponent 0, we haven't calculated the number inside the bracket, since it's raised to power 0, and everything raised to power 0 is equal to 1. Now, what if we have, for example, 2 power 3 times 2 power 4? 2 power 3 is 2 times 2 times 2, 3 times. Let's write it. It's 2 times 2 times 2. This is 2 exponent 3 times 2 exponent 4 is 2 times 2 times 2 times 2, 4 times. And this is 2 exponent 4. And the answer is, let's count how many 2 we have. 1, 2, 3, 4, 5, 6, 7. So we have 7 times 2, which is 2 exponent 7. Since it's 2 multiplied by itself 7 times, so it's 2 exponent 7 according to the definition at the first of this chapter. Okay. So here, we can directly add the exponents instead of writing it in this form 2 times 2 times 2, because if we have very big numbers, if we have, for example, 2 power 100 times 2 power, for example, is 72. So this expression, we can't write it 2 times 2 times 2 10 times and 2 times 2 times 2 72 times. It takes a very long time. So we can here add the exponent directly. Since 3 plus 4 is the same as 7, we can write 2 power 3 times 2 power 4 is equal to 2 exponent 3 plus 4, which is equal to 2 exponent 7. Again here, it's equal to 2 per exponent 100 plus 72, which is equal to 2 exponent 172. So the formula is a power n times a power m is equal to a power n plus m. A very important trick. This is in the case of a multiplication. If we want to multiply a same base powers, so we can add the exponent directly and the base remains the same. What if we have division? If we have, for example, 3 power 10 over 3 power, for example, 3. This is equal to, let's write it 3 times 3 times 3, 10 times 3, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay. And here we have 3 times 3 times 3, and we can simplify 3 with 3 and 3 with 3, 3 with 3. It remains how many 3? 1, 2, 3, 4, 5, 6, 7. So it's 3 exponent 7. So again, here we can directly subtract the exponent instead of writing it 3 times 3 times 3 times many times. We can write it, it's equal to 3 exponent 10 over 3 exponent 3 is equal to 3 exponent 10 minus 3, which is equal to 3 exponent 7. And of course, we know that this is the same as a 3 exponent 10 divided by 3 exponent 3. These two writings are exactly the same. So the formula is a power n over a power m is equal to power n minus m. So if we have two powers with the same base, we can subtract the exponents. And of course, don't miss the condition that a doesn't equal to 0, since we can divide by a 0 number. This is the second property. Let's talk about the next one, which is if a number has two exponents like this. What if we have 2 power 3 power 2, for example? This is equal to power 3 multiplied by itself 2 times. So it's 2 exponent 3 times 2 exponent 3, which is equal, here we have multiplication of 2 powers with same base. We can add the exponents, so it's 2 exponent 6. And clearly, if we multiply the exponents, we can get directly 6. So we can write 2 exponent 3 exponent 2 is the same as 2 exponent 3 times 2, which is equal to 2 exponent 6. And the formula is if a power has 2 exponents, then we can multiply these exponents directly. So it's the same as a power m times n. Again, the next one, what if we have 2 powers with the same exponent, like if we have 2 power 3 times 5 power 3, for example. So this is the same as 2 times 2 times 2 times 5 times 5 times 5, and then we can multiply 2 times 5 times 2 times 5 times 2 times 5 to get 10. So directly I am going to write it. We can multiply 2 times 5, so we can write it 2 times 5 exponent 3, which is equal to 10 exponent 3. So if we have 2 powers with same exponent, we can multiply the bases together. And the formula is a power n times b power n is the same as a times b power n. The same in the case of the division. If we have, for example, 10 power 5 over 2 power 5, we can write it. We can divide directly 10 over 2 since they have the same exponent, so it's 10 over 2 exponent 5. And as we know, 10 divided by 2 is 5, so it's 5 exponent 5. And the formula is a power n over b power n. It's the same as a divided by the exponent, and don't miss the condition b does not equal to 0, since we can divide by 0 number. Okay. Now this is the properties of the power. Let's prove that a exponent 0 equal 1. How to prove that a power 0 equal to 1? So a power 0 is equal to, as we saw, we talk about the formula or the property a power n over a power m is equal to a power n minus m. So if we take, for example, a power 3 over a power 3, and this is equal, if we want to use this formula, is a exponent 3 minus 3, which is equal to a exponent 0. And of course, we all know that a exponent 3 over a exponent 3 is the same as 1. So 1 equal a exponent 0. And this is the proof of the property f power 0 equal to 1. Let's now talk about the sign of a power. Sign of a power. What do we mean by the sign of a power? Okay. I want to talk about what if we have, for example, minus 7 exponent, for example, 50. I want to know the sign of this number without calculating it. Is this number positive or negative or negative? Okay, let's see. What if we have, for example, minus 2 exponent 1? Here it's minus 2. It's minus 2 multiplied by itself one time, so it's minus 2 here. And if we have, for example, minus 2 exponent 2, it's minus 2 times minus 2, which is equal to minus times minus plus, and 2 times 2, 4. Minus 2 exponent 3 is equal to minus 2 times minus 2 times minus 2, which is equal to minus times minus is plus times minus minus, and 2 times 2 times 2 is 8. And for example, minus 2 exponent 4 is equal to minus 2 times minus 2 times minus 2 times minus 2 4 times, which is equal to minus times minus plus times minus minus times minus plus. So the sign is plus, and 2 multiplied 4 times is 16. So we can guess the result or the conclusion. So here the exponent is odd number, it's negative. The exponent is odd number, it's negative. Here the exponent is even number, it turns to positive. And here the exponent is even number, it's a positive number. So if we have a for example, minus something, minus a power n, and a is positive number. So it depends on n. If n is odd, it's negative, and if n is even, it's positive number. So the result is it's minus a if n is odd number, and if it's plus a if n is even number. So as an example, the first one minus 7 power 50, what is the sign of this number? Clearly it's positive. It's greater than 0 since 50 is even. So if we take, for example, minus 30 to exponent 105. So it's negative. No need to calculate. It's negative directly since 105 is odd number. 105 is odd. If we have, for example, 3 exponent 27. It's always positive because here we have a positive number. So a positive number raised to any power is positive. So it's positive number. And this is about the sign of a power. Now, what about the powers of 10 and the negative exponents? First, I'm going to talk about the negative exponents. Like if we have, for example, 2 power minus 3. What is 2 power minus 3? If we use the calculator to calculate this number, it gives 1 over 8. And 1 over 8, we know that 8 is 2 exponent 3. So the formula is a exponent minus n is equal to 1 over a exponent n. This is the formula of the negative exponent. Again, if we have, for example, 1 over 2 exponent minus 3. Again, if we use the calculator to calculate this number, it gives 8, which is equal to 2 exponent 3. And the formula is 1 over a exponent minus n is the same as a exponent n. These two forms of the negative exponents, for example, let's take some examples. If we take, for example, 2 exponent minus 3 over 3 exponent minus 2. Here, 2 exponent minus 3, we can flip the negative exponent to the denominator, so we can write it 2 exponent 3 here, because 2 exponent minus 3 is the same as 1 over 2 exponent 3. And 3 exponent minus 2, again, we can flip 3 exponent minus 2 to the numerator, so we can write it 3 exponent 2. So it's 3 exponent 2 over 2 exponent 3. Again, another example, if we have, for example, 1 over 2 exponent minus 4. It's the same as 2 exponent 4, and it's 16. 2 times 2 times 2 times 2, 4 times 16. Again, another one, if we have a 5 exponent minus 2, this is the same as 1 over 5 exponent 2, and it's equal to 1 over 25. Okay. Now let's talk about the powers of 10. What if we have 10 exponent 2? What is equal to 10 times 10, which is equal to 100? If we have, for example, 10 exponent 4 is equal to 10 times 10 times 10 times 10 4 times, which is equal to 10,000. Okay, so clearly the formula here, 10 exponent n is equal to 1 0, 0, 0, etc. 0, and here we have n zeros. This is if we have a positive exponent. What if we have a negative exponent, like if we have 10 power minus 2, for example? It's equal to 1 over 10 exponent 2, which is equal to 1 over 100, and it's equal to 0 0.01. 10 exponent minus 1, for example, is equal to 1 over 10, which is equal to 0 0.1. So clearly here, if we have 10 exponent minus n is equal to 0 0.0, etc., 0, 1, and here we have n numbers before, after the decimal point. N numbers after the decimal. Okay, let's take some examples. For example, if we have how to write 8,000 in the form of a number times a power of 10, it's 8 times 1,000, 8 times 1,000, which is equal to 8 times 10 exponent 3. What if we have 0 0.000, for example, 14? It's equal to, first we have 14 times 10 exponent. We have 1, 2, 3, 4, 5, 5 numbers after the decimal point, so it's minus 5. So whenever we have 0 points, a negative exponent, and if we have, if we don't have decimal points, a positive exponent of 10. Let's take a practice. Write in the form of a power of 2, for example. Let's take, for example, 2 power 3 times 2 times 2 power 2. This is equal. Here we have the same base, then we can add the exponents. We have 3, don't miss that here we have 1. If we don't have an exponent, then we have 1, so it's 3 plus 1 is 4 plus 2 is 6. This is the first one. The second one we have, for example, 2 power 10 times 2 power 3 over 2 power 7, and this is equal. Here we have multiplication of 2 powers with the same base. We can add the exponents, so it's 2 power 13 over 2 power 7, which is equal to 2 exponent 13 minus 7 is equal to 6. Another one, if we have, for example, 0 0.2 power 3 times 8 times 10 power 3. Let's take here 68. Okay. So we want to write in the form of a power of 2. So it means that we have to write it as 2 exponent something. Okay. First of all, we have many methods to solve this situation. First, we have here 2 numbers with the same exponents. this number and this number, they have the same exponent, and we have a formula. If we have the same exponent, we can multiply the numbers. So we can write it 0.2 times 10 exponent 3 times 16 is, we can factorize 16, right? The prime factorization of divide by 2 is 8, divide by 2 is 4, divide by 2 is 2, and divide by 2 is 1. So it's 2 power 4, 2 exponent 4. And it's equal to 0.2 times 10 is 2 exponent 3 times 2 exponent 4. And here we have two numbers with the same base, two powers of the same base. We can add the exponents, which is equal to 3 plus 4 equal to 7. Thank you very much. And don't hesitate to ask me any question if you have any question. This is my email address, Hashim Akil at gmail.com. Thank you.